So let's now leave pure hydrocarbons and introduce some functional groups. And what better type of functional groups to introduce than those with some nice electronegative atoms, in particular some oxygens and then a little nitrogen there. So anyway, we got these four compounds that are going to match up to these four spectra. So what I would do is the first thing is I would look and see, well, how many broad hydrogen peaks do I expect? There's obviously two types of hydrogen in L, three types of hydrogen in M, 4 in N, and 3 in P. So therefore we've got a 2, 2 3s and a 4. Thus we can immediately assign a couple of those molecules just by consideration of the number of peaks. So we'll start with propan 1-ol, and what I hope you would agree is that there are 4 types of hydrogens there. You have the pink ones here, furthest away from the alcohol, then the blue, and then the green closest to the alcohol. And of course the alcohol proton here. Most of the time an alcohol proton or an acid proton are going to be singlets. The acid proton obviously because there's no hydrogens on the adjacent carbon, but just the involvement of these hydrogens in hydrogen bonds and so on can mess around with the splitting, and so we would expect to see singlets. So I'd expect to see 4 peaks, one of which is a singlet for the propan 1-ol. Propan 2-ol here, well, let's get a singlet for the alcoholic H. I've got one type of hydrogen on the secondary carbon that has the alcohol in it, and then these two methyl groups are indistinguishable, thus just 3 types of hydrogen, the big methyl with 6 there, and then a 1 hydrogen and a 1 hydrogen. Going to the propanoic acid here, you've got of course the H for this, which is not only going to be a singlet but would be very, very far downfield. And then as well as that 1 proton, we've again got the methyl and then the CH2 next to it. And I'll be addressing this in a minute. Notice this is an ethyl group that is attached to something that's not going to do the splitting. So this would definitively just be a nice little ethyl group. And then finally, we get down to the cyanide or the nitrile. Again, we see this ethyl group here, just the 2 types of hydrogens because the group, functional group, the nitrile, has no hydrogens at all in it. So the first thing I would then do is I would say, look, we've got a spectrum that has 2 signals and we've got a molecule from which I expect there to be 2 signals. So let's immediately say that L is the nitrile. Now let's see where those peaks come from. 2 sets of peaks. You have a big triplet and a smaller quartet there. Well, the triplet is going to come from hydrogens or on carbon that is next to a carbon with 2 hydrogens. So obviously that's the pink, the methyl bit, and then the quartet is going to be from hydrogens that are adjacent to 3 hydrogens. So that's the blue ones because those are adjacent to 1, 2, 3 hydrogens on the methyl group. And again, this little pattern here is extremely diagnostic of an ethyl group that has no further splitting, a triplet, and then a quartet. The 3 hydrogen triplet, the methyl group, the 2 hydrogen quartet, the CH2 group. Now, of course, if we look now at the other molecules, we see again there is that nice little ethyl group there, and it's an ethyl group that should have no further splitting, this carbon, because this carbon is attached to another carbon that has no hydrogens on it at all. So can you find the next ethyl group? And there it is right there. Okay, so P must be associated with propanoic acid. Just as a confirmation of that fact, there's the acid proton. We'd expect to be a singlet way downfield, and there it is right there. So P is the acid. So now we just need to decide which of M and N are propan 1-ol and which is propan 2-ol. And of course it's fairly obvious simply from the number of peaks. Propan 1-ol has 4 peaks, propan 2-ol has 3 peaks. So there's the propan 2-ol going for the 3 peaks. Start to assign, we expect a huge big peak for those 6 pink ones, and they will be split into a doublet because they're next to the carbon that has 1 hydrogen on it. So there indeed is the big doublet. We have the singlet associated with the alcoholic, and then we have a big mess here that's going to be associated with the blue hydrogen there, split into, one would imagine, at least 7, depending upon what this H does, but we'll assume the H does nothing. So split into 7 because of its proximity or its adjacency to the 6 pink ones. And you can see 1, 2, 3, you can vaguely see 7 peaks there. So fairly sure that that's the blue one. Leaving, of course, N with its 4 peaks to be associated with propan 1-ol, which of course has the 4 expected types of hydrogen. getting clocking on through. There's the methyl, a large group split into 3. Next one here is going to be the CH2 there, and of course it's not part of an ethyl group, it's part of the middle of a propyl group. So it's quite nastily split because it's been split by the 3 pink ones and by the 2 green ones. Then we get a nice singlet here. Well, the singlet is probably almost certainly going to be due to the alcoholic proton. And then finally we get these green ones here, which are split by the 2 blue ones, not split by the alcoholic proton, because again we don't expect that to take part in splittings at all. So the green ones we would just expect to be associated quite nicely, split into 3 because of the 2 adjacent blue protons, and there it is there. So there we are, a signing of the 4 non-hydrocarbon molecules. Hope that made sense.